Okay, hello and welcome to this GarrettCom training presentation on how to set up basic spanning tree protocol on your GarrettCom switches. So what we're going to do is we're actually going to set up a quick network here. If I show you what switches we have using the IP camera, if I fire that up, we've got 3 switches here, connected 1, 2, 3. And we've got a console connection, and we'll be using this console connection to, going back to this PC, to configure each one in turn, and then what we'll do is we'll cable them up and we'll see spanning tree protocol in action. Okay, so let's get started. Okay, so step number 1 is to take the console connection and plug it into the first switch. So we'll do that now. Is that the right way around? Yes, it is. Okay, so we made a console connection to the first switch. So what we need to do now is fire up our terminal emulator. So let's minimize this. I'm just going to use Hyperterm, try and keep it as simple as possible. Fire at Hyperterm, name our connection, select the COM port 4, importantly set the speed, we want to use 38400 and flow control set to none, and here we have our window. Let's adjust that to the correct size and press return, and here we have a connection to the switch. So we're going to log in using the default username and password, which is manager and manager. And the first thing we're going to do is I'm just going to show you a tool here is to restore it to the factory defaults, which is the kill config command. Enter that command, wipes all of the previous configuration. These are lab switches which I've been using for various purposes. So we want to wipe the configuration, have a nice blank canvas, and reboot those to clear anything in the memory. So we want to reboot the switch, click yes. Do we want to save the configuration? No, we don't, because we just cleared it. We want to wipe it. Okay, so let's leave that to, actually I'll let it run through. It doesn't take too long at all to boot up, and you can see the boot sequence. So it finds the operating system from the memory, loads the configuration once that's loaded, so the basic default configuration this time, and then gives us the hit enter to log in. It's done a login prompt again, manager and manager, and again we see these DHCP, bootp and default IP addresses messages pop up on the screen. Previous video on setting the IP address details, I ran through what each of these messages mean. It's just a helpful tool to get you up and running. But let's recap what we did there. So when we want to set the IP address on the switch, we just type in ipconfig, then the IP address equals 192.168. We're using the 40 network, so 192.168.40 is our network, and we want to use switch number 1 to be IP address number 1, and we're going to use a default mask. We don't need any more information other than that, so keep it simple. That's the IP address. Now what we need to do is we need to enable spanning tree protocol. Now if I type in STP, it says it's an invalid command. The reason being is that by default, the GarrettCom switches have been set up to run rapid spanning tree protocol, which is the newer, improved, faster version. And this video wants to cover the original standard, the older standard, which, okay, it's a bit slow, but a lot of people still want to use it. So that's what this video is all about. So let's do that. So if we want to use the older version, the STP, rather than the newer version, the rapid spanning tree, what we're going to do is we're going to use a command called set. And again, if we want to see what options we have there, follow it with the question mark, and we see here in the list set STP. Control C will break you out of that, so set STP, and then we want to see how to finish the command. Again, follow it with a question mark, and here we can see set STP type equals either STP, the vertical line means or, and these brackets mean an option, so STP or RSTP. So we want to type set STP type equals STP. Forgive me, STP. And here it says set STP or RSTP. This is what the command does. Click return, and it says it's done. That's all we needed to do. So just to run through that again, set STP type equals STP. Done. That's the command you need to convert it from rapid spanning tree back over to the standard version. Again, Typically most people will use Rapid Spanning Tree. It's newer, it's got lots of more improved features, it's faster, incredibly much faster than Spanning Tree Protocol, but there's still people who would need to use, for various reasons, the original version. Okay, to set up any STP information, we need to go into the STP mode, so we're just going to type that in now. So STP, and here we are in the STP mode. You can tell that by the brackets with the STP next to it. So if we want to see what commands we have available, just type in the question mark. And here we have at the top section we have all of the commands which are related to this mode, and then down here we have all the commands which are related to any mode. So here, for example, we want to just set STP. If we just want to turn it on with the defaults and nothing else, all we need to do is type in STP followed by an enable or disable. In this case we want to enable it. Do we want to turn it on or off? Yes we do. We want to turn it on, so STP enable. Done. STP is turned on. That's all we really need to do. So let's have another look at the commands. So we can see a bunch of show commands. If I back out of here, exit. Actually no, I might as well have a look around. So we can change things like the port status of individual ports. We can adjust the timers, the cost per different links, and the priorities of different links to make one preferred over another. And the whole process of Spanning Tree Protocol is to prevent what's known as a broadcast storm or a switching loop in the network, where the switches get confused and will send the messages round and round to each other indefinitely. And it's a feature of Ethernet. Spanning Tree was designed to manage the redundant links, the spare links in your network. If you have spare links, it's a good idea. That way, if one link goes down, then you've got a backup link to get to that switch. The only problem is without some kind of management, the switches get confused and then they don't know which link to use, basically. So I don't want to delve too much into the theory of Spanning Tree, just the commands needed to enable it on the switch. So, okay, if we want to see some of the show commands, I'll show you that now. So it types in show STP and then follow that with a question mark, and we can see the two commands which basically shows us all the information we need, so nothing too complicated. So show STP, and then we can see the configuration, the config, and it gives us all the details. For example, is it enabled, what ports it's enabled on, what type of STP we're using. Are we using the Rapid Spanning Tree or are we using the normal version? Here we see the bridge ID. The bridge ID is the switch MAC address, the name of the switch. Here we see this one here. And the other important one to note is the designated routes. The designated route is the boss of the Spanning Tree network. Who's in charge? Who's making all the decisions? And we can see the bridge ID of the designated routes for master switch, the root bridge in the STP network here. If these two if these two IDs are the same, that means that this bridge, this switch, is the boss switch. It is the root switch. It's the root bridge. Here we can see the default priority. All of the switches out of the box get a default priority of 32,768. If you study a bit more about Spanning Tree, you'll see there's a reason for that, but to know that they all have the same priority. Default timers are being used here. 15 seconds forward delay, hello timers, max age. We won't cover the details of these timers. All you really need to know is that if you just enable it and you use the defaults, 9 times out of 10 it's going to work perfectly for you. There's very few situations that you actually need to go in and adjust those timers. Really, it's one of those turn it on and off you go jobs. It normally works just great. And there's only a very few special situations where you need to go in and change any of these parameters, and it's really of an advanced configuration for more of an advanced user, because if you change these parameters it could improve things, but if you don't know what you're doing it can seriously hose up your network. So best advice is, unless you're an advanced user and you really need to change those, don't change those at all. Okay, so that's it done. That's Spanning Tree. Oh, forgive me, I missed one command. So show STP, that was the configuration, and the final one was the ports, wasn't it? If we see up here, show STP config, or we can see the ports, type in ports, And here we are. Here, these are all the ports on the switch, and the screen's not quite large enough. It's just a question of the viewing area on these videos aren't quite large enough. The larger the size of the video, the larger the file size is, so we can set about file size here. We can see the port numbers, the type of the ports, the priority, the cost. Again, don't worry too much about these details, but all that information is there for you if needs be. There's nothing, this is probably the port number and the port state are the two most important things here. If it's being used, it's forwarding. If it's a backup link, a spare link, it will be blocking. Okay, so that's the two terms to look out for, and those states will be listed here. So just run through show SDP config, shows you the details of what this ID is, what timers we have, and who's in charge. And show SDP ports shows you what port is doing what in the network. And we'll come back to these when we set up the other two switches. Okay, so whenever we make changes, we need to save those changes. Okay, that's done. And let's hop over to the next switch. So what I'm going to do is, if I bring up the web camera, what I'm going to do is, so you can see me do this, I'm going to take the console port out of the one switch, plug it into the next one in the row. Okay, so go back to the console port, and we can see we connected to the next switch. So what we're going to do is we're going to do the same, login, manager, and manager. And this time I'm going to do the config without all the gubbins and the explanations and the show only question mark, so you get a nice clean configuration. And we'll do it one more time, so just to reinforce the commands for you. So first of all is I'm going to kill the config. Yes, I want to kill the configuration. And nice blank canvas, reboot. I want to restart the switch. Yes, I do. Do I want to save the configuration? If I'm killing the config, no, I don't. Normally you would do. If, for example, you were just restarting it for some other reason. If you're wiping the config, just click no. Let that run through. I'll just pause. Actually, you can pause. Okay, I'll just pause the video for a moment just to shorten things. Login, manager, and manager. There's messages just interrupted my output there. And it's going to type in an IP address so we can get rid of those messages. IP equals 192.168.40 is our network. The next switch in the line is going to be number 2. Press return. So if I go back to the camera, this is going to be number 1, this is going to be number 2, and this is going to be number 3. Keep it nice and simple. 192.168.40.123. Okay. Now we need to go to set STP type equals STP. Done. Go into the STP mode, STP enable. Done. That's all there is to it, and save. And that's it done. Again, pop back to the camera, just take out the console port, plug it into the next console cable into the next console port. Get back to the config. I'm going to kill the configuration, so you don't need to see that here, but I'll be back in just a moment. Okay, so I'll log back into the switch. I need to give it an IP address because I just wiped the configuration. I'm just going to return out of there because there's messages were interrupting the output of the commands. Config IP equals 192.168.40.3. You only get those messages while you haven't assigned an IP address. Once that's done, they just go away. Again, set STP type equals STP, and go into the STP mode, STP enable. Done. Back out and save. And that's it. That's the configuration. So now what we need to do is plug in all the cables, and away we go. Okay, so first things first, what I like to do is going to connect these 3 switches together. The 3 switches are lined up nice and neatly on the desk. Obviously in reality they'll be spread out over a distance, but this just is to make our life nice and simple. But logically it's the same thing. So we have one end of the cable to here, into the next switch. Those 2 links came up, you saw those green lights change, and now we have switch number 1 connected to switch number 2. Next step is to get the next cable, plug that in, and then plug it into the next switch. And now what we have is called a bus, where there's one switch to the next switch to the next switch. Now the problem is, if we lose one of the links, these two can't talk to this one. If you've got more links in the chain, you create two halves of the network. And that's the shortcoming of the bus. The bus is nice and simple, one switch to another switch to another switch. But the problem is, what happens if we lose a link? We need to have a spare, right? And this is where spanning tree protocol comes in. So bear with me 1 second, I'll get another cable. Okay, so this is our next cable. What we're going to do now is we're going to connect the last switch in the chain, here, all the way back to the first switch in the chain. And what that does is it creates a ring. So we went from a bus 1, 2, 3 to a ring where we go 1, 2, 3 and then round. So you can see my hand when we go round again to here. 1, 2, 3 and around. 1, 2, 3 and around. By creating a ring, what we're doing is creating the simplest and cheapest form of redundancy, because on the desk these cables cost about £1, but if these switches were linked together via fibre optic cables, those links could cost quite a lot of money. So the number of links is obviously, the more you have, the more redundancy you have, the more reliable your network, but also the more expensive. And rings are popular because they provide a good level of redundancy for a good value for money. So we have, if this, for example, this link were to go down, we can still get to this switch at the end via the first switch. We just go 1, 2, 3. They can all talk to each other. If this link goes down, 1, 2, 1, 2, 3, we can still get there. So that's the idea. We're converting a bus into a ring, and the problem is, without the spanning tree, these spare links would cause problems. And what we'll do at the end of this video is I'll show you how it's to verify it's all working properly, and I'll show you the effect of a switching loop, a broadcast storm. Okay, so let's go back to the command line and let's see what this looks like from there. So if I just close that down and bring up the command line. Okay, so here we have the switch. If I just go show STP and config, we can see now that this particular switch is the boss. It's in charge, and basically what this means is typically it's the oldest switch will become the boss switch, and if you want to find out who's in charge, just type in show STP config and look for the matching bridge IDs. If we do show STP ports, there's not really much else to talk about here because everything else is at the defaults. Show STP ports with an S. Post show STP ports. Done. Here we can see that port 1 is being used. These others aren't being used. They're just disabled. They're not doing anything. And port 3 is being used. That's fine. If we hop over to the next switch, now that we've got all the LAN cables, all the Ethernet cables connected, we can actually just telnet to it. So telnet to 192.168.40.2. Give it a second, and here we are, manager, we're logged in. So we don't actually need to use the console cable anymore, and just go show STP config. Just show the details there, and we can see here that this bridge ID ends in 80, and the root bridge, the boss, is 70. So it sees that the third switch in the row, it sees that the second switch sees this switch here, the third switch is the boss, he's in charge. Now if you want to go to show ports, forgive me, show STP ports, 2 seconds, STP ports, and here we go, and we can see again this one's forwarding and this one's forwarding as well. So these two ports on the this one and this one are both forwarding traffic. Finally we need to go to, if we log out of here and go back to the first switch, yes, we want to log out. Be careful when telnetting from one switch to the other. You can make sure you're going to log out from the switches, otherwise you tie up those telnet sessions. Okay, so we're back on this one, and I typed in show ipconfig just to make sure we're back on the third switch. So we're back here now, back on the third switch. Okay, so let's go to the first one, telnet, to 192.168.40.1, and go to that one, log in, and we should see that one of these ports is disabled or blocking ports, because you can only use one. There can only be one active path around the network at any one time. So to prevent those loops, those broadcast storms, you need to block one of the backup links, one of the redundant links. And let's see that now. So we'll see it in action, show SDP ports, and here we can see that port 1, this first port here, this port is working, it's forwarding traffic, but this port here, port number 7, is blocking. Here you can see port 7 is blocking. This means that this link here is the redundant link, it's the backup link, it's the spare link. So the idea is that if this way around the network, to go from switch 1 to 3 to 2, one of these links was to break, then the switches would talk to each other, have a think about things, and then eventually this link would come back up, allowing the 3 switches to talk to each other again. And that automatically works. It automatically happens. It's like a self-healing network, to coin a phrase. And yeah, so it's an automatic process. The only problem is with spanning tree protocol, it can take between 30 and 50 seconds for that to happen. It's nowhere near as quick as rapid spanning tree. So what we're going to do, in actual fact, is I'm going to set up a ping, and I'm going to show you this working in action. Okay, so bear with me 1 second. In actual fact, it shouldn't take that too long. If I bring up the command prompt using this shortcut from my desktop, here we have, if I ping, I always like to ping my own IP address to make sure that's working first, which is 100. I can see that's working. And what I want to do is ping each of the switches in turn. So ping number 1, and I can't get there. So it's worth just double checking, so bear with me. I'll tell you why, because I disconnected my cable from there. Control C. Just so you know what's going on, and I don't want to confuse you too much, I'm actually using the console connection to connect to these switches via my PC. So my PC goes to the console, to the switches, and there I'm telnetting from one to the next. So to make it simpler, I'm going to take this connection and disconnect it. And what I'm actually going to do is take the LAN connection and plug it into one of the machines, the first one here. So it was failing because I didn't have an IP connection directly from my computer. Now that I do, it's going to take a few moments for the switch to recognize that, because it's spanning tree protocol and it's a little bit slower. It's a little bit more cautious than rapid spanning tree. So I'll see you in a few seconds. Actually, what I'm going to do is I'm going to show you that in action. So if I do ping and then follow it with a -T, it's a continuous operation. It was too quick for me. So what this is doing is continuously pinging that IP address, and that will come in useful later. If I do Control C, I can stop that. I want to make sure if I go up arrow, I can see the previously entered command. Type in 40.2, press return, I can get there. And 40.3 is the third switch. Now I can get there as well. So what I'm going to do is I'm going to ping the switches, and I'm going to break one of the links and let the switches recalculate the path and use the backup link to get back around. And what we'll see is that the pings will work at first, we'll break the link, it will take about 30 to 50 seconds to recover, and then we'll see the switches come back in. Okay, so let's just show you that again. So to show you that on the between the switches, this particular link is spare, it's redundant, it's not doing anything. The switches are going from switch 1 via this cable to the third switch, and then via this cable they're going to go back to the second switch. So we're going to go 1, 3 and 2. Now what happens is if we break this link, I won't be able to reach these two switches from this switch until the switches have a chat and think about things, and they work out that this is a spare link and they can talk to each other via this spare link. And then once this link comes up, I'll be able to talk to these two guys again, but again a more direct route. Bang, bang. Okay. I'm connected. My PC is connected to the first switch, and what I'm going to do is I'm going to ping the third, so that I can get there normally. But when I disconnect this link, there will be an interruption in the service, and the interruption will continue until this backup link comes up. So I'm going to ping from the first switch to the third, kill the link, and watch the backup come up. So I'm back at the command prompt. I'm going to ping the third switch continuously. Off I go. Ping, ping, ping. It's all working fine. Now what I'm going to do is I'm going to disconnect this link here. Off it goes. If I go back to the command prompt, I can see, oh look, straight away the link has died. I can't get there. Now what I'm going to do is I'm going to leave this running, and what's going to happen is the switches will eventually figure out that they can go this way around, and the time it takes to figure that out is between 30 and 50 seconds, and that's the reason why rapid span tree has become so popular, because it recovers so much faster. And here we are, it's recovered. So you saw the topology. I didn't change anything from there on, but we recovered. The switches learnt the new route around the network, and if we go back to the switches, we can see previously that this switch was blocking on port 7 and it was forwarding on port 1. If I do the same connection, which I've lost now, so I need to just reconnect there, so close that down. No, if I just minimize this for a moment and just double click on Hyperterm. So it's going to telnet back to that switch. If you remember, I disconnected the console cable. Again, this time I use a telnet connection to 192.168.40.1, which is the first switch, and go across. Login manager, event manager, and if I go show STP ports, do you remember the first one was forwarding on port 1? Now it's disabled, and check it out. We're forwarding on port 3 because that's what my PC is connected to, and port 7, where it used to be blocking, is now forwarding. So switches have realized that's a spare port and they can be used safely. And what I'm going to do now is I'm going to reconnect to that reconnect that cable. So if I show you the pings are still going, happy as Larry. If I reconnect that cable, we'll now have another interruption, which is the make. We had the break initially, and now we've got the make, and we'll have another delay while that happens. Show ports, and we can see that port 7 has gone back into blocking mode, and port 1 has gone back into listening, and it's starting to use port 1 again. And when it goes from listening to forwarding, we'll know that it's ready to be used, and we'll see the pings come back in. So this is spanning tree in action as well. So it's spanning tree configuration, spanning tree verification, and spanning tree demonstration. And here we have the replies have come back in. It's learned about the original path. It's come back in. If we go, and we can see it's moved to forwarding. So here we had it was down, and port 7 was forwarding. Then we reconnected port 1, and then port 7 went into blocking, and now port 1 went into listening, and finally port 7 is still blocking. It's still there in case we need it, and port 1 is finally up and running, and our pings are working away. We got connectivity, and that is the end of the spanning tree video. I hope this has been interesting and helpful, and on behalf of GarrettCom, I'd like to thank you for your time. Goodbye.